All right, so just before I start, just so I know where I'm pitching this at, put your hand up if you've heard of GraphQL. Keep your hand up if you've ever used it in a project. Keep your hand up if you're currently using it in production. OK, perfect. That's exactly the level I was expecting. So if you've already used it a lot, I might cover some. I'm going to go over a fairly broad overview here. So if you already used it a lot, I might cover some stuff you already know. But hopefully there's going to be something in here for everybody. So let's jump in. Actually, this talk isn't about GraphQL. It's about using Absinthe to hit this Bulmer peak here. For those of you who don't know, this is an ex-KCD comic. If you get your blood alcohol concentration just right, you get superhuman programming abilities. This is me in the nested office attempting to get here. I actually ended up somewhere over here, so takes a few tries. Who is this guy? Why is he qualified to talk about GraphQL? So I work at Nested. You've already heard quite a bit about us. This is us in our office in Dallington Street. This is us every time we make a deploy. We do continuous deployment. No, I'm kidding. This is a team building event, which we did recently. And I noticed Adam's on there. That's coincidental. Maybe he just really likes podiums or something. I don't know. So yeah, I introduced Elixir at Nested just over a year ago. We already talked a bit about what we do. And since we introduced it, we now have a major production system built around Elixir and Absinthe, which is GraphQL server implementation for Elixir, and a few clients that revolve around that. So we've had a good amount of experience over the past year actually using this in production. So I want to start off with a little bit of a quick story. Shortly after I joined, we were approached by the CTO, and he's like, OK, we need this admin panel. It's just a simple CRUD thing, super easy. It's probably about 2 weeks' work for you guys, which I'm sure you've all heard this before. And these 2-week projects rarely actually get completed in 2 weeks. And this one was no exception. So we started building this thing, and we still haven't finished it. And it's morphed from what was once a very simple CRUD application into a sort of gargantuan beast, which is essentially our core business software that we use at Nested to track almost everything that we do internally in terms of business processes. Goes through there. So the point of this little story is that when you start out in a project, it's very rare that you actually know what you're going to end up building. The requirements are usually not known ahead of time. So you have to be careful to pick the right technologies and the right choices that are going to make your software flexible to change over time. Now, I think Elixir is a good choice for this, and I also think GraphQL is a good choice for this. I'm going to try and explain to you why. So this is what I'm going to go through. What is GraphQL exactly? I know a lot of people are confused about this. Why would you want to use it in your particular use case? It's not suitable for all use cases. And I'm also going to cover some GraphQL fundamentals, and specifically how you can actually get started using Elixir as a GraphQL server. So what is this GraphQL thing anyway, and how does it compare to REST, which we all are intimately familiar with and know and love? Try not to overcomplicate this here. It's just a query language for APIs. Nothing more and nothing less. If you look at this graph, it sits in between your GraphQL server. This doesn't have to be Elixir, obviously. And you've got your consumers or clients of your API. And the language they speak to each other that's where GraphQL sits. And GraphQL can wrap multiple other APIs or data stores or almost anything further back, which is what we see here. It's, essentially conglomerating these 3 things into a common interface. Now, when I was trying to find what people were confused about in GraphQL, I went to Google and I put in, is GraphQL? And I wasn't disappointed. There is a lot of confusion about what this is. So I'm going to go through these questions and try to clear this up. So the first 3 are all variations on a theme. No, it is none of these things. GraphQL doesn't have anything to do with how you store your data, or even if you store any data at all. It's completely agnostic to what kind of data store you're using. It's independent from your ORM. It's not any kind of database. And I know this is confusing because GraphQL sounds a bit like SQL or SQL, which actually is a database query language. So I think that's where some of the confusion comes from, that people think, oh, GraphQL, it's like SQL for graph databases. Like, that's not what it is. It's an API language. So is it open source? I can give you a solid answer for that. Yes, it is. Facebook open sourced it in 2015. So you don't need to worry about vendor lock-in with this. These three questions are quite subjective, and these are my answers here. So is GraphQL RESTful? Like, not really. Is it hard? Well, I don't think it is, and hopefully I can get that across to you as well. And is it worth it? Now, I'm not going to answer these here because this sort of is the talk, so we'll skip over those for now. Again, very subjective. Is GraphQL good? Well, it depends. It depends on your use case. It depends. I mean, it's such a subjective question. And I find it quite funny that these bottom three, it's a bit of an indictment of our industry that we can simultaneously consider one technology good, dead, and the future. I wonder if this is a bit of a front end leaking over here. But so it's not dead. And I actually think that it is the future for certain classes of applications. Just for a bit of proof that it's not dead, I mean, it's been around for 2 years, for goodness sake, it's not dead yet. Here are some major companies that are using GraphQL in production. And what you might find interesting here is that although Facebook invented GraphQL, they've got direct competitors like Twitter and Pinterest who are also using it. So they're clearly not worried about vendor lock-in. You shouldn't be either. Some common objections to using GraphQL. The top three of these are just completely wrong. And I hear these a lot. So I want to dispel this. GraphQL is slow. Well, GraphQL is a API query language. It's independent from a particular implementation. Now, you might have one implementation of a GraphQL server that's slow, but GraphQL itself isn't slow. It doesn't have to be. In fact, in many cases, it's faster than REST because you can get away with making less queries. And I'll dive into that in a bit. There's no lock-in. I've already addressed that. And as far as it being less discoverable than REST, it provides you with a schema. So if anything, it's more discoverable. The bottom two are valid objections. It can be harder it can be a little bit more opaque to consume client-side. Now, there's a lot of good client libraries out there, like Apollo Relay for JavaScript, probably a lot of other ones that I don't know of. If you're using a very simple client, it might be a bit harder. And caching. So you can't just whack a CDN in front of a GET request with GraphQL and expect it to just cache all of your shit. It's a little bit more in-depth than that. There are strategies you can use here, but it's a bit beyond the scope of this talk. So just to recap here, what is GraphQL? I don't want anyone to get confused about this, hopefully, anymore. It is a query language for APIs. It allows you to expose potentially multiple data sources as one unified graph. And it's independent from your transport or your storage layer. So it sits in front of those things. Let's move on to the meaty part. Why would you use it? So why would you consider using GraphQL over going with what you're used to, which is REST? And that's the question you're really asking here is really, as developers, there's almost an infinite plethora of technologies that we can choose to learn. And we can't learn everything. So sort of like as this self-defense mechanism, you can come up with reasons about why you shouldn't learn one particular thing, because you just can't learn everything, and that's completely reasonable. So what this question is really asking is, I already know and I understand REST. Why would I go and learn this new thing that seems complicated and scary and has all these hairy bits all over it? Right? I can't immediately see what benefit that's going to give me. And that's a fair and valid point. But a lot of the time, when we're faced with decisions like this, you have to use something before you can understand the benefits of it. So I'd imagine that everybody in this room, I mean, definitely, there was a time when everybody in this room didn't understand what a function was or why you might use it. You look at a function and be like, why would I do that? I can just copy and paste the code here. Why would I bother using a function? It's this weird, complicated thing that I probably don't need. Well, if you're here and you write Elixir, obviously you know what a function is, and hopefully you know why they're important. And the reason that you know that, the reason that you learned that, is because you blindly went ahead and tried it and used it, and you came to understand why that's important. I'm going to try and get across a little bit about why you might use it here. So there's three major benefits of GraphQL. It's declarative, it's compositional, and it's discoverable. And these words don't really communicate much, so I'm going to try and explain the first two by this little analogy. So imagine that we have this restaurant. This is my favorite restaurant. And they do really good burgers, and they do really good salads. So some of you might have seen this already. This is not my idea. There's a very good Medium article about this, which I encourage you to Google for. But it's a great analogy. It really gets the point across. So I go to this restaurant, and if I want a burger, that's fine. There's shrimp burgers, so I can queue up in the queue to get a burger, and I can wait in the queue. And then I can take my burger, and then I have my burger, and I'm happy, right? Or if I want an avocado salad, I can do the same for the salad queue. So everything's going great, but what if I want a shrimp salad? So there's two options I've got available to me here, right? I can queue up for the salad, the avocado salad, I can get my salad, and then I can be unhappy because it doesn't have shrimps in it. That's called underfetching. You didn't get all the data that you needed to do what you wanted to do. My other choice is I can queue up for my salad, I can get my salad, and then I can queue up for my burger, I can get my burger, and I can take all the bits of the burger that I don't want, and I can throw them away and put the shrimp in my salad. And now I'm happy, because I got what I wanted, right? I got my shrimp salad. But that seems kind of wasteful. I had to throw away a bunch of food, and I had to wait in 2 lines, so I had to wait twice as long. So that doesn't really, I'm not very satisfied with this solution either. This is called overfetching, where you have to request more data than you actually need. So the traditional way you might think to solve this with REST, and this is probably where a lot of you thought of immediately, is you can say, oh, why not just get salad with shrimps? Well, yes, that does solve this particular problem. But what if you come in and you want your shrimp salad without the avocado, right? Or now you want only the tomato from the burger with your salad. So then you say, okay, well, we'll just add salad with tomato, salad with bun. You add everything. What you end up with is if you follow this approach to its logical conclusion, you end up with one endpoint where you configure exactly what you want via parameters. That's exactly what GraphQL is. It's one endpoint where you tell the server exactly what you want, and you get it all back. The difference is that instead of evolving it in this ad hoc, difficult to reason about, complicated way, it's built in from the beginning in a structured way. So this is what GraphQL is, and this is what I meant when I said declarative and compositional. So that you can imagine GraphQL as more like a buffet. So you wait in one queue, you get to your buffet, and all the food is here. So you can say, I want my avocado salad, I'll take my avocado, I'll take my lettuce, I'll take my shrimps, and you take it all, and you have your shrimp salad. And you only had to queue once, and you got exactly what you wanted, and you didn't have to throw anything away. So it's declarative in the sense that as the client, as the customer, you went to the buffet and you were able to declare what you want. You didn't just get some set menu foisted upon you by the server. And it's compositional in the sense that you can pick from different foods and compose them into one salad, which is what you actually wanted. So that's declarativeness and composability. There's also the third thing that GraphQL gives you, which is discoverability. And this is why I find it funny that some people have the complaint that REST is less discoverable than GraphQL. GraphQL has a concept called a schema, which is essentially a graph of all your data, and you can inspect the schema without actually having to make any queries. It's strongly typed, so you know exactly what you're going to get back. This is useful in general. It's especially useful if you're dealing with something like a strongly typed language. If you're developing an iOS client, you're working in Objective-C or something like that. It gives you built-in versioning. There's a structured way of removing and deprecating certain fields. It's self-documenting in that you can explore the schema, and I'll show you an example of that a bit later on. And it also encourages the idea of documentation as code. And as Elixir developers, we like this. We have module docs, right? So put your hand up if you think module docs are a good idea. Yeah, they're useful. And from my experience, when you don't have documentation as part of the language, what you get is no documentation. And when you have it built into the language, it gives you that extra bit of tooling that you need so that people actually think, okay, you know what, I'll add this bit of documentation here because I know it's going to come up in this beautiful generated documentation later, and people are actually going to be able to use it. So GraphQL gives you that as well. In REST, frequently, the documentation is an entirely separate thing from your API. And it's often either, if it's existent at all, it gets out of date very easily, and it's tedious to write. You have to write the examples. It's just not as easy to use. So to recap, GraphQL Benefits, it's flexible to change. It allows you to add to your graph, add to your schema over time, and deprecate, remove fields, change things in a structured way. If you were doing it with REST in the way that I showed with the parameter, for example, you would have a much more ad hoc way of managing this sort of thing, or you'd have to resort to versioning. Who here has ever used the V1, V2, V3 approach to versioning a REST API? Keep your hand up if you think that works really well. One guy. I think maybe it can work in some very specific scenarios, but usually what you end up with is a sort of foot in both camps where you've still got people using V1, you can't get them off, and you want them to use V2, and you end up supporting both. One of the other major benefits, which I actually didn't touch on before, is faster iteration. So because it's declarative, because the client can say what it wants, what you actually end up with is faster development iteration. And this is something Powell was talking about this morning, about getting that loop, right? You want to get that loop as fast as possible because it allows you to iterate faster. This is an advantage that GraphQL has because you can say what you want as a front-end developer or even a full-stack developer. If you want to get some more data or change what you're getting, you don't have to go to the back end, add the new endpoint, and implement all that, and do the testing, and then come back and then do your work. You can just say, oh, I'll just fetch this thing now. And then you have it straight away. You can get on with your work. And if you say, OK, well, what am I getting here? You can inspect the schema. You can look at what you're getting. And you don't have to go ask the back-end developer or look at the code or anything. And third benefit, it's omakase. So the client picks what they want. They don't just get foisted with a bunch of data they didn't ask for. So in answer to the original question, should I use GraphQL? These are some use cases that I think you should probably consider it. If you're aggregating multiple disparate APIs into one. So a prime example that a friend of mine recently did was, he was a banking application. They had a whole bunch of different legacy systems. And you're not realistically going to be able to rewrite this legacy mainframe that's been running for 30 years and is written in Fortran and has some terrible API written in that nobody is using anymore. Then realistically, you can't rewrite that. But what you can do is you can write a layer for it that then exposes that as part of a GraphQL schema, along with a bunch of other services, making it a lot easier for clients to access. If your requirements are changing over time, GraphQL gives you a lot of tools to be able to do this well. If you have multiple types of client requirements, so at Nested we have, just as an example, we have our admin tool, and we also have some reporting systems. And both of them use the same schema. And they query it in very different ways, but they're both able to use the same schema, and they're both able to get what they need. And certainly, if you're accessing any kind of graph data, GraphQL is the right choice. And almost all maps of how we have our data are actually graphs. Relational data, like in a relational database, is a graph as well. It fits very well to the graph concept. So this wouldn't really be complete if I didn't say some examples of where you probably not the best idea. This one, if you have a very simple API, especially if you're exposing it to a lot of either dumb or very simple clients, GraphQL is not the best idea. Certainly, if you have external requirements for your API and you have other software developers that really don't want to use GraphQL, obviously you're restricted in that. And if you have a legitimate need for CDN caching around GET requests and things like that, there are ways that you can make GraphQL work with that, but it's probably easier if you just use plain old REST in those cases. So let's get into some fundamental concepts of GraphQL. And there's a lot to the GraphQL spec, which I'm not going to get into everything. I couldn't possibly do that in 40 minutes. But hopefully I want to give enough of an overview so you can at least basically understand what it's about. Here we go. So this is a GraphQL schema. And this is written in, the language, I suppose, is called GraphQL. It looks a bit like JSON, but it's not JSON. It's its own thing. And we can see here that it all starts with this top-level keyword here, the schema. And inside the schema, we have a field, in this case, called query. That's their query there with a lowercase q. Now, what this means is that field returns an object of type query, query with a capital Q. And if we want to see what we can get inside that object, we look inside query, and we can see we've got two fields in here. We've got the burger field, which returns you a burger, and the salad field, which unsurprisingly returns you a salad. And you can also see I've just thrown in this here just to illustrate it. You can put inline documentation in here. And that documentation will show up when, as a client, you introspect the API. So you can say what your fields do. You can document almost everything in GraphQL. You can document types, fields, objects, everything. So the schema represents a graph of all of your data. It's got fields and types, and it's got descriptions and other metadata, such as deprecations, things like that. So the important thing to remember is that at the top level, I'm not sure if this is enforced by the spec, but this is the convention, and you'll have a very hard time if you do anything different. You've got three top-level, like sort of special top-level fields, right? These are essentially actions. So the fields are called query, mutation, and subscription. And by convention, again, it's not enforced. Query is for fetching data. This is essentially kind of analogous to a REST GET. Your query should not really have side effects. That's surprising if it does that. Mutations are for changing things. So if you want to update some data, you want to delete something, change the state of some object, send an email, these kinds of things are mutations. And subscriptions is something built into the GraphQL spec that allows you to subscribe yourself to real-time updates. And this is really cool as well. You get 5 primitives, what are called primitive scalar types in GraphQL. So there's two sort of types in GraphQL. One of them is an object, so like that would be like a burger. But eventually, an object must have a subselection of fields. And eventually, you want to actually get to some real data you can use. So those are called scalar types when you actually get to a type that you can get some data in there. Now, GraphQL spec comes with 5 built-in ones. It comes with integers, floats, strings, booleans, and this special thing called ID. And it seems pretty Spartan, but you can very easily create your own scalar types. So one thing you might, can anybody think of something that's obviously missing from here that you might need? Yeah. Dates, great one. Anybody else? That's actually, so optional is what's called a modifier. So you see this a bit later in that if you specify your type like this, then it is optional by default. But if you put an exclamation point at the end and put a bang on it, then it becomes required. So that's something slightly different, a type modifier. But date or date time is an excellent one. Another one might be a decimal type. But actually, it's very easy to define your own. So you can define your own custom types. And what that means is you say, this is the type, we'll just call it date time, and then you specify in your server however you want to serialize that. Usually you'd serialize it into a string. And then on the client, you'd specify how you want to deserialize it. So for a date, you'd probably choose to serialize to an ISO timestamp. So this is the full schema that we might have for our restaurant. This little bit you've seen before. Now that little bit was, that snippet was missing something important. We hadn't actually told it what the burger and what the salad types actually looked like. So this is how you define types. So we can see here that this is the field name here, and this one here is the type that field returns. And when we specify the type, that's the shape of the object that we're going to give back. So the burger has this shape where you specify your number of shrimps that you want, your amount of lettuce leaves, whatever fraction of a tomato you want. It's stretching the analogy a bit here, but you get the idea. And all of these here are, I've just gone for simplicity here. I didn't want to get into the details, but all of these here are optional fields. So what that means is that they can give you null back. So if you put a bang on an exclamation point on the end, then it has to come back with a value, or you have to provide a value if you're sending it. But in this case, any one of these can be null. So if we look at how you might issue a query to get some response based on this schema, it looks like this. So we've got a client on the left and our server's up here. And see, the client is making, this is what the query looks like. So this is, again, is written in this GraphQL format, which is not JSON, but kind of JSON, but not really. And we wanted our shrimp salad, if you remember from the analogy before. So we know we can get shrimps on the burger, so we ask for the shrimps on the burger. And when we want these things on our salad, we don't want the dressing, we left that out. So we send that request to the GraphQL server, and the GraphQL server implements the GraphQL spec and then does something to generate a response. And then we get the response back as JSON. And you'll notice that the response we got back is in exactly the same shape as the data we asked for. So in this way, GraphQL is very predictable. It gives you back this data in the shape that you asked for it. And another important thing to note here is, because GraphQL is transport channel agnostic, this communication layer here, it could be anything. It can be regular HTTP request. It can be HTTP2. You could do everything over WebSockets. You could do it with carrier pigeon. Really, it's up to you. GraphQL spec does not make any attempt to define how you send the queries and responses. Generally, you'd use like a post request to do this. So now we move on to, now we know vaguely what a GraphQL server is, and we know what a schema is, and hopefully we know how we can issue queries against that schema. Let's have a look at how we could actually get started implementing a GraphQL server in Elixir. And this is probably the most important bit of the talk, because one day, if you don't learn how to do this, one day you might find your boss comes to you and says, hey, we really need a GraphQL server. And if you don't know how to do this, some bright spark might decide to write it in Node. And probably if you're here, you don't want that to happen. So pay attention. If you're going to write a GraphQL server in Elixir, use Absinthe is my advice. It is the best GraphQL server library. We've had an absolutely great experience with it at Nested. We've been using it since the beginning. Never had a problem with it. It allows you to define your schemas. So instead of that GraphQL language we saw earlier, you define your schema as a DSL. So you write regular Elixir code to define your schema. So they're easy to read. It just looks like regular Elixir. Absinthe is high performance. The maintainers place a lot of emphasis on performance. And it comes with a lot of tools to help you do that. And it's got a lot of advanced features. And most importantly, in my opinion, it's very well maintained. And the maintainers are very responsive. So if you have a problem, you can actually ask the maintainers, and they'll generally reply to you in the same day. And we've had bugs. We've run into bugs in Absinthe at Nested, where I just got in contact with one of the maintainers, Ben Wilson, his name was, and said, oh, hey, Ben, we've got this bug. And he was like, oh, shit, you're right. Hang on, give me a sec. And then an hour later, he's made another release that fixes it. It's very rare to find that kind of responsiveness. They've also got a book out, by the way. I'm not affiliated with the Absinthe guys. I just think they're really cool. You should check out the book if you're interested in using it. So here's how you might define a example schema using Absinthe. So you've got this module that you call your my schema or whatever you want to call it. And you need to use these two things, absinthe.schema and absinthe.schema.notation. The .schema allows you to specify queries and fields, and the notation allows you to specify the types. So as you remember from earlier in our schema, we have our burger type here with these 4 fields. And they're just macros. You just call object burger, and it creates a GraphQL object, and then specify the fields that you want. And the second argument is the type of the field. And then you remember earlier from our root level field called query, you have a special macro called query. And then you put all the fields that you want to be available on query inside there. And you can do the same for mutation. You can do the same for subscription. I haven't included them here because, well, my slide wasn't big enough, really. The only difference here from what you've already seen is that we have to actually tell Absinthe how to get that data. We've told it what kind of shape to expect and what kind of shape to return, but we haven't told it how to actually get it. So that's what this resolve function does. And that resolve goes inside the field and tells Absinthe how to get the thing that you want to render. In this case, I've just gone for a very simple example. This can be anything. This can be an API call. It could be getting something from your database, anything you want, really. The only thing that it has to do is return a tuple with OK in the object or an error tuple. Another benefit of GraphQL is that you can specify errors on individual fields. And it's very easy to do that. So let's say that this resolve failed for some reason. Maybe the chef was sick or something. Then we could return the tuple like error and then put a string in here or something like chef was sick. And then if a client makes that query, they're going to get back their salad still, because presumably that was pre-made in the fridge. But instead of getting their burger back, they'll get an error that says, oh, hey, we couldn't do this for this reason. That's super handy. Cool, so hopefully that's clear enough. Absinthe gives you a lot of other cool stuff. So one common problem, and this is not just with REST APIs, it will happen with any kind of data fetching, is N+1 query problem. Put your hand up if you know what the N+1 query problem is. It looks like about half of you. Excellent. So the N+1 query problem would happen if you're querying, like, let's take an example. Let's say you have a number of users, and each user can have multiple pets. Now, a naive way of getting all the users with their pets would be to say, okay, give me all the users. Great, now I've got all the users. Now for user number 1, give me all their pets. Right. Now for user number 2, give me all their pets. User number 3, give me all their pets. And this is actually a very common problem in Rails applications, particularly because the way that active record lazy loading works, it makes it very easy to accidentally stub your own foot and do this kind of thing. Elixir with Ecto is a lot better. It forces you to use preload in such a way this isn't usually a problem, but it can become a problem again in GraphQL. So you want to avoid doing this. You want to avoid doing N+1 queries. What you want to be able to do is the minimum number of queries to get the data that you asked for. And Absinthe gives you some very powerful tools to be able to do that. Built in, it's got this asynchronous field resolution, which is a very simple way of doing it. You also got a tool called Data Loader, which is sort of separate, but also maintained by the Absinthe maintainers. And Nested is quite a major contributor to this library because we use it extensively. One missing piece of Absinthe is the documentation around Data Loader, which there isn't any. If you go to Data Load, it just says to do, write some documentation, despite the fact that this is what the Absinthe core maintainers actually use to do all of their heavy lifting when it comes to data loading. It's very powerful. You can plug multiple backends, multiple databases, multiple APIs into it, and it'll work out the right way to load all of your data in the most efficient way possible. So if you want to look into that, you can either get on the Absinthe Slack or buy the book, or come to our training session tomorrow. We might touch on it, I don't know. Absinthe gives you complexity analysis. So one of the issues that people might have with GraphQL is, okay, well, what happens if someone makes a query for your entire database? And that's a legitimate concern, right? Because that could bring your application down to a halt, opens you up to denial of service attacks, this kind of thing. You can put the brakes on that by using this complexity analysis function. Now, we don't use this at Nested. We haven't run into any problems with overly complex queries. But it essentially allows you to say, look, you're only allowed to query a maximum of 100 fields or something like that. And it also comes with some excellent instrumentation tools. Now, instrumentation is really important, and I'm going to show you one of the really cool things you can do with it on the next slide. So this is a real dashboard that we use at Nested. We built this dashboard using something called Datadog and the Absinthe instrumentation. And what this shows, these are all fields which we've marked as deprecated. So we want to get rid of these. And this shows the number of times they were queried in the past 24 hours. So out of our entire schema, we can see exactly which deprecated fields are being queried, who's querying them, how much they're being queried, and everything like that. So this is super handy because if you want to remove a field in REST, probably what you have to do is not remove the field, create a version N+1 of your API, wait for everybody to be using that version, and then get rid of the old version. And that's going to take you, I mean, that could potentially never happen. Whereas in GraphQL, you've got a much clearer and more granular idea of what deprecated fields are being queried and how you can get rid of them. So we use this a lot. This is super handy for us. This tool called Graphical, this is not made by the Absinthe maintainers. This is made by, I believe, the GraphQL people. But it does ship with Absinthe, and especially if you're using Absinthe with Phoenix, it's very easy to get this set up. You just add a couple of lines to your router, and you can get this tool set up. And Graphical is kind of like a playground for issuing queries and playing around with your GraphQL schema. So I put together this little demo video, and I thought it'd be cool to use an actual real example instead of an artificial example. So I'll just pull it up, and then you can see. So this is what Graphical looks like if you install it on your server, you can go to like localhost 4000/graphical, and it'll come up here. Now, I was going to do a live demo of this, but I decided that'd be too dangerous, so I stuck with the video. The first place you want to go is this docs on the right-hand side. So none of these docs are written manually, by the way. They're all generated by the server. And this is a real schema that we're using at Nested. This is what we call our public schema, which is a very small subset of our schema, which we expose for use with public-facing tools like the website, for example. So we can see right away that we've defined two top-level fields here in our schema. We've got query and mutation, which you guys have seen already. And we can go and look at what sort of things we can query on that. So we can look at that root query type, and we can immediately see there's 4 different fields in there that we could query. And we can see the documentation, so we can see what they are. So that's pretty cool. So Graphical lets you write the queries and play around with it. It's got a lot of nice features like autocomplete, and it's got this underline here that shows you when you've done something wrong. So that's a tab completion. So we're just going to try this validate postcode as an example. So if you go to nested.com, and we got a box there right on the home page, and you can put in your postcode and press get a valuation or whatever, and that actually uses this field in our GraphQL schema. So what we can see here is Graphical's already telling us some helpful stuff. So it's got the little red squiggly underline there. That means there's that query as we've written it is not going to work. Why is it not going to work? Well, it's given us 2 reasons. So firstly, field validate postcode of type postcode validity must have a selection of subfields. What that means is postcode validity is not a scalar type. So it's a type with more subfields in, so we have to tell it what subfields we want. The other thing that it's missing here is an argument, and we haven't looked at this just yet, but they're quite simple. So if you look validate postcode right here, you'll see that it's got this syntax here with the braces. So that takes 1 argument, which is postcode. And that's kind of just like query params for a GET request. It's basically analogous. So that's a required argument, and you can see it's required because it's got that little bang on the end there. So we need to give it a postcode. So let's just add those in. The other thing here is that this is still wrong because we haven't given it a selection of subfields yet. So we can look at what those are by going to the postcode validity type, and that'll tell us what subfields we're allowed to query on this field. So let's just see if it's valid or not. We can run that and we get the result. That's not a valid postcode. I would be very worried if it was. So maybe we want to find out. Maybe we want to find out. Well, why was that? Why was that invalid? We can also optionally query the reason. So that's because it's an incorrect postcode format, right? So let's try an actual correct postcode format this time. What happens now? That's still invalid, but for a different reason. Now it's because Nested doesn't serve this area yet. There's one more bit of this example where just add the normalized postcode as well. This is just for client convenience. So if the client sometimes has the user enter a postcode that's not formatted correctly. So what we can do is return that formatted correctly. There's some like moderately complex rules about it, and then the front end's able to display that to the user, so it looks a bit more beautiful. Cool. So that's just a very, very, very quick run through of Graphical. I encourage you, if you do want to use GraphQL, spend a lot of time in this. It's very easy to just play around with your schema, and it'll really help you understand how to use it. So it's a great learning resource. Cool. So that's pretty much it. So you might be asking yourself, okay, well that's all great. Now I hopefully now I understand what GraphQL is and why I might want to use it. Where do I go from here? So I can recommend the official GraphQL documentation. What I will say something that it is quite dense. So if you find yourself looking at it and not understanding and going away and then coming back later on and trying again, that's normal. I've spent a lot of time trying to decipher what's going on there. It's very thorough, and it covers all of the weird and wonderful bits of the GraphQL spec that I didn't touch on here. So it is worth sticking with that. I'd also recommend if you're on the, by the way, if you're not on the Elixir Slack, you should definitely get on there. It's really, really good. A lot of useful channels and resources on there. So you can get on the Elixir Slack and you can go to the Absinthe-GraphQL channel and you can hit up the Absinthe maintainers. You can ask questions about Absinthe. They're super helpful on there. So I definitely recommend you do that. And I know this has already been mentioned, but just quickly to recap, at Nested we are doing a workshop tomorrow at our offices where we're going to dive more into GraphQL, basically hands-on how to build your own GraphQL server with Elixir. So if you're interested in that, just come grab us at our desk out there. And that's it. Thank you very much for listening.
Thank you.
One more thing real quick. If this is how to get in touch with me, on Twitter I'm at SamPhilipD, and sometimes I write on SamuelDavies.net.
Thanks for the talk, Sam. I'm wondering, how does authentication work in GraphQL?
So authentication can work. It's essentially not really, the GraphQL spec leaves it up to you to define how you want to do authentication. The way that we're doing it is we send an authorization bearer token with our post requests, and then we have a middleware, essentially, that looks at that, decides whether that's a valid user or not, and then puts the user in something called what's called a context, which is passed down to every resolver. So then in the resolver, you can just say, who's the user that's resolving this? Are they allowed to access this resource, yes or no? Yeah, I mean, that's the pattern we're using, and it's working well for us.
Oh, wow. That's like 2 in a row. Yeah.
Have you used GraphQL or Absinthe over non-HTTP, like WebSockets or something? And why would you do that? Why wouldn't you?
I have got it working over WebSockets. The reason that you wouldn't do that is because WebSockets are so much more tricky to keep working in production, I've found. Like, there's a lot of load balancers that they don't play well with. It's just, the path is just not quite as well trodden. You absolutely can do that. You absolutely can have all of your GraphQL communication go over WebSockets. And I believe Powell was talking about that last night, actually, that's what they're doing. They're using WebSockets only. We're not doing it just for essentially compatibility and robustness. Like, WebSocket connections don't always work.
So 2 questions. First, for caching, is there any reason you couldn't couldn't do a query over GET and cache it that way?
We were talking about this yesterday, actually. I believe you could do that. So you could choose to issue your GraphQL query as a GET, and maybe you'd encode your query as like a base 64 parameter or something, and then you could transparently cache that using Varnish or anything like that. The issue with that is that there's a limit to the length that a GET request can be. And I think with certain complex GraphQL queries, you're quite likely to hit that limit. Now, there's other ways around that, and you can have something called, I can't remember what they're called, server-side queries or prepared queries or something, where you actually have a list of preset queries that the client is allowed to ask for, and you identify them by ID. So then your client could say, I want to execute query 16 with these arguments, for example, and then that approach might work well. So that's why I said there are ways that you can do it. It's not completely trivial.
Okay, thanks. The other thing is, for the n+1 query issue, is there a good way of handling filters on 2 different objects? So for the user pet example, all pets who are dogs and all users who are 25 or over, for example. So where you'd usually do a join or some sort.
Maybe. I don't know. I don't have a good answer for you. You'd have to. I suspect you probably could do it using data loader, or worst case scenario with Absinthe, if none of the tools provided do it for you, you can write custom middlewares that can load data in almost any way you want, using batching and things like that, which we have done in a couple of cases. So you probably can do it. For the interest of simplicity, I would probably just issue both of the queries and then filter in software in that particular case.
Okay, thank you.
Thank you. Okay, I think we can wrap up. And then thank you, Sam. Round of applause.
Thank you.
Thank you.